Hello all. Here we are going to talk about DC chopper fed with separately excited motor. We have team of three members: Gomathi, Riaz, and Aarthi of Tyagaraja College of Engineering. At first, what is a chopper? A chopper is basically a DC to DC converter whose main function is to create an adjustable DC voltage from a fixed DC voltage source through the use of semiconductors. There are two types of choppers. They are named as AC and DC. And now talking about AC chopper, AC link chopper. In case of an AC link chopper, first DC is converted to AC with the help of an inverter. As I say, Inverter is used to convert the DC to AC. And then AC is stepped up or stepped down by a transformer. You can use a step up or step down transformer, which is then converted by DC by a diode rectifier. Diode rectifier are used to convert it to DC from the transformers. AC link chopper is costly, bulky and less efficient as the conversion is done in two stages. DC chopper. And coming to DC chopper is a static device that converts fixed DC input voltage to a variable DC output voltage directly. This is one of the point. And the chopper can be set as a DC equivalent of an AC transformer as they behave in the identical manner. This kind of choppers are most efficient as they involve one stage of conversion. Just like transformer, chopper can also be used by step up or step down with the fixed DC output voltage. The choppers are used in many applications all over the world inside various electronic equipments. Chopper system has a high efficient fast response and a smooth control. You can see a basic chopper block diagram. DC motor is separated in three categories: separated excited motor, self-excited motor, and permanent magnet. Self-excited motor is further classified in three types: shunt excited, series excited, and compound excited. And in these three, you can see that compound excited is further classified in two types: cumulative component and differential component. It's then said as long shunt or short shunt. Separately excited DC motor. Separately excited DC motor has a field coil similar to that of a shunt wood DC motor. Usually in other DC motors, the field coil and the armature coil both are energized from a single source. The field of them does not need any separate excitation. But in separately excited motor, the separate supply provided for existence of both field coil and armature coil. Operating characteristics of separately excited DC motor. Both in shunt wood DC motor and separately excited DC motor field is applied from the constant voltage so that the field current is constant. Therefore, these two motors have similar speed armature, current and torque armature current characteristics. In this type of motor, flux is assumed to be constant. The speed armature current NLA characteristics. Speed of the DC motor is proportional to back EMF. Back EMF, no flux, you can change that. When load is increased, back EMF EB and the flux is decreases due to armature resistance. However, the back EMF decreases more than the pi, so that the speed of the motor slightly decreases with the load. And torque armature
characteristics.
Torque is proportional to the flux armature current. Neglecting the armature reaction, flux is constant and the torque is proportional to the. These are the characteristics you can see that in the separately excited DC motor. DC chopper fed with separately excited motor. Separately excited motor is connected with the chopper. The circuit using the DC chopper, the speed of the motor can be controlled. The three operations that take place here are the motor, regenerative braking, and dynamic braking. Buck operation of the chopper is similar to that of the motoring action. Here both of the voltage and current is positive. Hence the motor rotates the forward direction. When the switch is closed, the current flows from the source through the thyristor and the load to the source again. When the switch is open, the current in the inductor flows through the diode and the load forms a loop. During the T-on period, the voltage across the load is the sum of the voltage of the resistor. Inductor in the battery during the T-off, the source supply does not flow into the circuit. The voltage across the load is equal to 1 by T into the integral of Vs with limit 0 to T on. Hence Va is equal to alpha Vs where alpha is equal to T on by T. Since the inductor does not have any voltage, Va is equal to E plus I Ra. From this equation, E is formed. Here the torque is proportional to the current and the speed is proportional to the voltage. From the equation, E is equal to Ka omega S. Omega S is found Va and Ia are. The equation of the E is substituted. Hence the speed of the motor can be controlled using controlled by the varying value of alpha. Regenerative braking is similar to the boost converter cycle. The voltage is positive but the current is negative since it flows from the load. You can see the equation for the regenerative braking. Here when the switch is closed, the current flows from the load through the thyristor and then to the load from the loop. When the switch is opened, the voltage flows from the load, then the diode to the source. Here Va is equal to 1 minus alpha into Vs, and hence the equation of the speed is changed here. Dynamic braking. It is similar to the boost converter circuit. The voltage from the load flows to the resistor and heat is dissipated through the resistor. You can see a resistor in that. This is the speed torque speed characteristics. When the speed and the torque are both positive, it is monitoring operation, and when the torque is negative, it is the regenerative braking operation.
Thank you.